Hey everybody, welcome to the PC Perspective Podcast. This is episode 455 being recorded on, June 21st, 2017. I'm Ryan Shrout.
I'm Jeremy Hallstrom.
I'm the newly arrived after the summer solstice, Josh Walrath.
And I'm Alan Malventano.
You got to come up with something elaborate to talk about during your introduction like Josh does.
Well,
no.
To our Australian viewers, happy winter solstice.
Yeah. So is it today? Was it?
Well, it was
the
last night at 10
day.
o'clock in Mountain Time.
Yeah. Okay.
Like 10:21.
So longest days of the year.
Yes.
Great. Perfect.
Did you determine that from the Stonehenge you have erected in your backyard?
I wouldn't call that erected.
I wouldn't call it a Stonehenge. You know what that means.
There are pills and creams for both problems.
Yes, yes. And if your Stonehenge is erected for more decades, please go see a physician.
Yes.
Welcome to the show, everybody. Let me get that. There we go. So we record this on Wednesday nights, 7 p.m. Pacific, 10 p.m. Eastern at pcper.com/live. You can come watch the live stream, hang out in the chat room, and talk with us and make fun of us and all those types of things. Actually, as I say that, I make sure I have my chat client open. And of course, we have our Patreon campaign continuing to run at patreon.com/pcper. You go there. This is your place to recurringly contribute on a monthly basis to us. It could be $1 a month, or $3, or $5, or $10, or $50, or $1,000 a month, whatever you think we're worth.
Did you say $50,000?
Yeah, $50,000.
Okay,
50 or 1,000.
What's that, like 3 Bitcoin?
But like 50,000 would work too. Always, and when in doubt, round up. As is always the case, we greatly appreciate all of the Patreon supporters we have. Anybody who becomes a new supporter or increases their contribution during the show gets a call out on the show with whatever they happen to put in for their name in that particular place. We don't have any set up here yet, so we'll move on from that. We have another interesting thing to talk about. We, of course, that's not running. We had a discussion at the end of the podcast last week about
the laptop just crashed.
Coin mining and how you might be able to donate into our system in a way that doesn't involve direct monetary contributions. This is kind of like an interesting social experiment for us as well.
It's like donating your GPU power.
Yes. So We talked last week about the idea of the revitalization of mining and all that. We don't have to go into that in any more great length. But if you have a GPU, and it could be anything from an RX 460, 480, 580 to a GTX, 1060, 1080 Ti. Maybe you got 5 1080 Ti's in a system for whatever reason.
Probably not.
If you want to, and this is obviously, everything is still optional here. If you go to this story that we have at pcper.com, the title of it is "Donate to the PC Perspective Mining Pool: A Nice Hash How-To" that Ken put together for us. It will walk you through the setup process, which is really very simple. You download an application, you run it, it benchmarks your GPU. You put in this very long code here that is the Bitcoin wallet associated with the site, and then you tell it to start running, right? And you can have it run only at idle. You can just run it, you can manually do it if you want and say, I'm leaving for work in the morning, and start it up, and it'll run for 8 or 9 hours while you're there. Yep. And it basically uses your extra GPU cycles to donate to PC Perspective. Maybe you don't want to sign up for Patreon. Maybe you don't want to have to worry about, that extra charge on your credit card or whatever it happens to be. But you think this is another option for you. We love to have it. I think it'd be interesting just to kind of watch how things go, like what times of day and nights things are doing.
How much compute power we can get.
Yeah.
Just as a number is interesting.
It would be interesting to see, even if people who are watching the live stream just download it and do it like while we're running. I guess, does that impact their system stability if they do it while we're...
Your video playback might go to crap.
Yeah.
It might, yeah.
It might.
And that application
might be hard to hear us over the wire of the fans, too.
It's true.
The
make sure
application has an optional in there for Like only enable it when I've been idle for 5 minutes or 10 minutes, or you can set whatever you want.
I think the default is like
setting.
1 minute or something.
Might be a little bit too low.
That's a little aggressive.
Yeah, a little.
It is a little aggressive.
So I mean, it's a super simple process. There's nothing in our opinion that is kind of gray market or black market about it, or kind of like, I don't know what I'm trying to say. Something that seems like you're doing something illegal by coin mining or something like that, in case people are worried about it.
It's just math.
You're just donating math to like a marketplace sort of, and then just it pays out to a Bitcoin account.
Yeah.
You're giving us your math homework.
Yeah, basically. Your GPU could do your math homework for you.
Right. Yeah. But then we benefit from that math.
Yes.
Yeah.
Yes.
So and it's worth noting, it will cost you electricity.
That's true.
Roughly 7 to 10% of the value that you're mining at, depending on your card and efficiency and all that type of stuff. So I don't want you to think that it's completely for free, but it's no more than if you were running Folding at Home or Boink or any of those other things.
Or just playing games.
Or just playing games, right, continuously. So that's another option for you. Everybody, welcome to do it. We're going to watch it and see kind of what, if anything, happens. And maybe one person will do it. Maybe 100 people will do it. I don't know. We'll just have to find out.
Yeah.
I think it'll be
as it starts to get cooler towards the winter, like we can help you.
That's true.
We can help you heat your house.
The offset of the electric cost is the less heating you have to do. I'm looking forward to that, as opposed to the months of July and August.
Yes,
as well. So anybody who wants to check that out, that is, again, just go to PCPro.com. There's a story called "Donate to the PC Perspective Mining Pool," and it's a nice hash kind of walkthrough. Oh, cool. So now let's get into things that actually occurred this week. Two pretty substantial processor releases. We're going to start with the Intel Core i9-7900X. This is the Skylake-X platform. It launched on Monday, but we have been talking about it forever, right? We talked about the leaks coming through. We talked about when Intel made like their announcement without benchmarks. Basically, we're at the point now where we can talk to you about benchmarks. Pre-orders went up, and it will start shipping on the 26th of June, right? So the only processor...
Wait.
Go ahead.
Just one CPU? Which model?
Well, so from the 7900X and below are available for pre-order and will ship on the 26th.
So the middle of the chart to the right.
Yes. So as you look at this, 10 cores and below.
Gotcha.
10 cores and fewer. Okay. The 12 core will be in August, I think I was told. Yeah. And then the 14, 16, 18 will be in October. Okay. Right. So we talked about the specs. We don't really have to go through all this. This is the 7900X is the 10 core part, 10 core, 20 thread, comparable to, actually, if I go down to this table down here, this might be a little bit more beneficial. The 7900X compares to the Core i7-6950X from Broadwell E. Which those are both 10 core parts. And if you look at the specs, you'll see, the base clock is 300 megahertz higher now. The turbo boost clock is 800 megahertz higher. And the turbo boost, Turbo Boost Max 3.0 is 500 megahertz higher. And that can actually work with 2 cores instead of just 1. The cache actually is lower, but that's L3 cache, LLC. You actually get more L2 cache in that deal. Memory performance goes up. You get 4 more lanes of PCIe. TDP is the same, although that's kind of baloney, as we'll talk about at the end of this discussion. But the price is important too. When the 6950X launched, it launched at $1,700. Now it's $999 for the 7900X. Still a ton of money.
Sweet.
Don't get me wrong. $1,000 for a CPU is still a ton of money.
It's almost half off though.
Yeah, but it's $999.
Yeah.
Our favorite
How cool
number.
Is that?
Yeah.
It is.
Also worth noting on that table, I threw the Kaby Lake part in there, the 7700K.
Yep.
Just so you get a sense, right? So the clock speeds of the 10 core part
can actually hit,
like the turbos are close, right?
Yeah.
Now the base clock is definitely, it's 900 megahertz lower, so that's important to note. But in my testing, I never saw 3.3 as anything that was a sustained clock level.
Is it just a matter of, can you keep it cool enough?
Yeah, yeah, to a certain degree, yes. But the Intel algorithms are less sophisticated than that. They tend to just kind of like, I think the all-core turbo it's 4 gigahertz on this.
Okay.
Right? Whereas the all-4 turbo on the 7700K, I believe, is 4.3. Right? So there's...
It's almost like with all these numbers, they should publish that one.
Yeah,
with all these turbo boosts and stuff.
Yes, agreed.
So, what is the what's the difference between the Boost 2 and the Boost Max 3?
So
then?
Turbo Boost 2.0 is just maximum single-threaded clock speed.
Right.
But then Max 3.0 is
2 cores.
3.0 started with the 6950X product. It is one of the cores is your most favorite core, and it can go higher than all the other cores.
But I thought they changed that to 2 cores now.
It is, but it's still called Max 3.0. Now it's called Improved Turbo Max 3.0.
But it's confusing that you would have Boost 2, which is just 1 core, be at a lower clock rate than Boost Max 3, which is actually 2 cores now.
So basically, the 4.3 kit applies to all 10 cores.
Oh.
Right?
Okay.
Not all 10 running at once, but all 10 have the capability to run at 4.3.
Briefly. Okay.
Yeah. Whereas the 4.5 number is your 2 most favorite cores that they have selected at manufacturing, right? We'll be able to hit 4.5.
So the Boost 2 was the thing that relied more on like the heat capacity of like the heat spreader and stuff. Like so it could burst.
But again, I don't think it was deterministic per system. I think it was determined at production time and kind of
it's like a coded in we know that
that's the goal.
Yeah. It's right? Like we can run this fast for this many seconds in a row, you know, in a short burst just to get something done quick.
Is it sort of like a validated silicon lottery on a core?
Yeah. So they basically I don't know what they do at the production facility, but they basically run a test on all 10 cores. They used to determine which one had probably the least leakage at some voltage, right? And now they just do that to 2 of them. Okay. So
makes sense.
In theory, if you have 2 loaded single thread workloads, they would both run at 4.5 gigahertz. As opposed to previously, you'd have one running at 4.5 and one running at 4. And if you have 3 heavily loaded single-threaded workloads, you'd have 4.5, 4.5, and 4.0.
Make overclocking interesting.
Not really, because most of the time when you're running overclocking, you're just doing all cores.
You just turn all that crap off.
Like all cores, yeah. So, from new tech, we've got AVX 512. We talked about that. The rebalancing of the cache hierarchy, we talked about that. It is interesting now that I could show numbers to give you graphs like this.
We haven't talked about the cache hierarchy stuff, I don't think.
We talked about the redistribution of the capacity, I think, but not the latencies, which we'll talk about here. So the redistribution of cache, essentially what they did was, read the story for more detail. They are now focusing on more exclusive cache per core and less global shared cache per die, right? Okay. So where you used to have 256K of L2 cache per core, now you have 1 meg of L2 cache per core, right? And you can kind of see that, I think, in this diagram here, right? So on the left is the Broadwell E. You can see they shrink the shared LLC in order to expand the local L2 cache, basically prioritizing single-threaded, not single-threaded performance, but single-threaded workloads, more, what do you call it, like thread occupancy in one thread, like data occupancy in one thread.
You'd have a larger cache available to
that thread. Right?
Yeah. Data locality.
There you go. Yeah. Thank you.
That's what you want. You want stuff closer to the core.
Right.
You want a bigger pantry.
So basically, what that comes down to is, they're looking at workloads, how workloads are changing over time, and then same thing on GPUs, right? They kind of rebalance things as architectures improve, and this is that. It's just interesting because Skylake, the non-X, the consumer version, this is different than that.
Yep.
Right. So there is a more fundamental architectural change from Skylake to Skylake-X than there was from like Broadwell to Broadwell E.
Okay.
Right. Just kind of interesting to note. This graph is interesting because as a result of those cache changes, what you'll see is like the L2 cache is, maybe a little bit faster to about the same, but the L3 cache average latency is now lower. Is now longer. Yeah. Right. It's slower. And you can see that in this graph, right? So if you look at the first 3, the blue, red, and green are the 7900X, the new one, running at 3 different memory speeds, DDR4, 2400, 2800, and 3200, and it decreases, right? If you look at the L3 on the right there, from 33, 32, 31 nanoseconds.
It's not a huge jump over the previous generation.
Well, I mean, so keeping in mind that the comparison is the blue bar to the purple bar. You're going from 33 clocks to 26. Yeah. Right? It's noticeable.
Right, but the counter is that each core has more cache.
Correct.
Yeah.
Right.
So it shouldn't have to do that.
So what's
right?
interesting is we don't have to go through, like, they basically moved from a ring architecture to a mesh architecture. We did talk about that last week, right?
Yes.
Because we were able
touched
to,
on
we were
that
talk
part.
about that.
Yeah.
And so that is part of where these performance deltas come into play. Is just kind of the restructuring of the cache. You know, the L3 cache, a portion of L3 cache is now attached to each core, and at most 2 jumps to get to anything, but slightly further away on that individual mesh network. We talked about Max Boost 3.0. You can see that kind of at work. They enabled speed shift on this part, which doesn't sound like something that's super necessary on desktop parts. But if you look at this graph, especially this bottom one here, which is a zoom in of the one above it, you'll basically see that, actually, we'll start with this one. The green bar, which is the 6950X, Broadwell-E, had no iteration of speed shift in it. It takes over 250 milliseconds to get to its top clock speed, right? Its top clock speed's lower, but we're not, whatever it is, it takes over 250 milliseconds, which is a quarter of a second, right? It's a pretty long time in computers and in processor speeds.
That's an eternity.
The blue line is Skylake-X, the new part. It gets there to its top speed, which is much higher, in under 50 milliseconds.
That's a pretty big difference.
Big difference. Now, but if you look at Kaby Lake, it was improved even further, and they're more optimized for the consumer parts.
I remember that being one of their big talking
yeah,
points.
if you zoom in here, it's like it's just over 5 milliseconds.
Yeah.
To jump up there. So you still get a big improvement. So the idea is responsiveness will improve slightly if you're running in like balance mode on a PC and you take advantage of something like this. So it's something easy that kind of works to your advantage there. And then touching on the latency stuff again, this is kind of a return to our thread-to-thread latency discussions that we had a lot around Ryzen.
Mm-hmm.
They change quite a bit with Skylake-X. So this graph here shows ping times between thread 0 and all logical cores after that.
Yep.
Right. Some of them I can see go up to 19 for the 20 core parts, go up to 15 for the 16 core parts, and only up to 7 for the 8 core part. So what you see there is in the bottom left of that, where the logical core 1 is the communication from logical core 0 to 1. It turns out they're on the same core. That's the hyper threading communication. So they're sharing L2 cache. Boom, your latency is incredibly low.
Yep.
Right. When you go up above that, you're basically going into L3 cache immediately for Intel parts, which is why you get to jump up to 2, and it's kind of consistent all the way across the board. So notice the green line, which is the Core i9-7900X at DDR4 2400, which all these tests are run at, is over 100 milliseconds. Nanoseconds, not milliseconds, holy crap. Yeah, 100 nanoseconds of L3 latency from any thread, from any one core to any other core.
Yep. It's basically just like one virtual or logical processor trying to send a message to another one.
But the Broadwell-E and even back to 5960X's Ivy Bridge-E, right? Haswell-E, yeah, sorry. Those are pretty much the same. They kind of hover around 80 nanoseconds of that. The cache structure was not altered in those, but you can see what the change that Intel has done with Skylake-X does. Like you go from 80 to 100 nanoseconds of L3 latency. So it's going to have an impact in some places. Look at the 4-core, the 7700K at the bottom, the dark blue line that is the shortest. Its L3 latency is just over 40 nanoseconds. Mm-hmm. It's still using the ring bus. It doesn't have the mesh, but it has the fewest stops on that ring bus.
Yeah,
so therefore
it's a small ring.
Yeah, the latency, the average latency to get around is lower. Now the lighter blue line is the Ryzen part, and you can see we have the L2 cache is slower than the Intel one. Mm-hmm. You jump up to a little bit for halfway. That's when you're on the same CCX. And your latency is on par with 7700K, and then you get this big jump up to about 140 when you go up to cross CCX communication. Yep. We've gone over that before. So basically, the point of this graph, which took a long time to get to, is that the L3 performance on Skylake-X is worse than Ryzen, and we assume Threadripper for until the CCXs are expanded past, and then the AMD architecture, the Zen architecture, is at the bigger deficit.
And then
right. And you can actually improve performance, interestingly, by increasing memory speed.
Threadripper and EPYC, they got 2 and 4 CCXs. So that miss that
No, they have 4 and 8.
4 and 8. My bad. So that inner CCX latency hit going to come up more unless they keep.
Well, it'll be the same. I mean, it'll be just you're extending the line up top further out to the right. Right. So I assume, having not tested it, that the Threadripper part will just be that light blue line will go all the way out to 15.
Right.
You hope.
Or no, we're already at 15. It'll go out to.
It'll go out further, but it'll
go out
still
to
be the same.
30,
It should still be the same. The same latency.
It should be the same.
Yeah.
Unless something occurs for the die-to-die communication that I don't know about yet.
Right.
Because it's 2 die.
But I think what Alex was talking about is that
it's
the
the
Intel
area under
parts,
the curve.
but the Intel part, like the Intel parts, have larger caches per core, right? Now
Of L2?
Yeah.
Yes.
So unless you had a specific workload that was trying to communicate core to core, any given thread should hopefully not have to make that jump that takes longer.
Yes. In theory. Yes.
Right.
Correct.
So, because you could look at this.
Increasing the L2 cache would, in theory, allow you to do that. But I mean,
Yeah.
we'll talk about it in a second when we look at the gaming results. Sometimes you could probably increase that L2 cache as much as you want. It doesn't matter. If you have multi-threading going on and those threads need to cross-communicate,
Yeah, it doesn't matter
how big your L2
yeah.
cache is.
Yeah.
Yeah, because physics. I mean,
Still got to invalidate and
Right.
scrub. And
Right.
Fortunately for Intel, there's already some game developers working on fixes for
It is.
core-to-core latency.
I'll skip this graph, but you can improve it with memory speed and increasing the cache speed on there, essentially like the mesh frequency on it. You can improve it, but it doesn't improve it super dramatically.
Yeah.
We did use the ASUS board on this. I'm going to skip ahead to those gaming results. Oops, one page too many. Because we're talking about it. So the Ryzen 1080p gaming scenario is slightly brought back to life here with Skylake-X to a lesser degree, right? If you look at these graphs, the red bar is, let me make sure, the red bar is a 7900X, the blue bar is a 6950, green is a 7700K, and purple is the Ryzen 1800X. So what you'll see is, inevitably, the red bar is lower than the blue bar, or is even or below.
Yep.
And sometimes, like the Civilization 6 benchmark, it's substantially lower. Far Cry Primal is substantially lower. And then even in like Hitman, Rise of the Tomb Raider, GTA 5, it's a little bit slower. And keep in mind, that's with a significant frequency increase as well. 7900X is running, 300, 500 megahertz faster than the 6950X.
So it's like the speed increase is kind of countered
in this particular workload,
in gaming workloads.
In some cases, like Far Cry Primals and Civ 6 are exceptions to that.
Yeah.
And then you look at a game like Deus Ex Human Revolution that clearly has no CPU bottleneck in place,
right?
Because it's the same across the board. A more like reasonable example might be something like Rise of the Tomb Raider or Great GTA, right? Where Kaby Lake is faster than Broadwell E is faster than Skylake-X.
Yeah.
That's kind of the conclusion you come to.
Yeah, I mean, it makes sense.
So it's super ironic that all of the discussion that built up about Ryzen and kind of how its cache latency affected these particular gaming workloads, and then the work that developers are doing to try to alleviate some of that directly applies to this product. And Intel's sitting there the whole time going, "Oh Jesus, like we're gonna have to deal with this." Like, rooting for AMD to maybe come out with those fixes.
Well, I think they were saying, "Oh Jesus!" Like before Ryzen came out, and there was a big push from AMD.
They were
side.
saying, "Oh Jesus!" and then they kind of broke the ice with Ryzen. They went,
yeah, and then
this will be a lot easier story to tell now."
Yeah, they're like,
but it's a totally open door now for the AMD engineers and the AMD fans kind of go, "Ha, see, it wasn't just us." Right now, there's a lot of talk that goes into why Intel did it versus why AMD did it.
They are still doing better than Ryzen in a lot of these. Just saying.
Yes. The argument is there, but it's also true that it's $500 more expensive processor.
Yes.
But whatever you get into, like the top available AMD Zen part.
On the flip side, for the cost, Ryzen looks pretty damn good.
Oh yeah.
It's
it's interesting to see that kind of recycled out.
Yep.
We've talked about this too long. Overclocking was great. Well, overclocking was pretty good. We were able to get up to 4.6 gigahertz all cores.
All the time.
Yeah, full time, 4.6 gigahertz. at 1.28 volts.
For a 10-core part, that's pretty good.
But we hit 100C several times. And this is with a 240 mil all-in-one cooler.
Well, again,
maybe a little bit.
But I will say,
again, it's 10 cores.
I will say it ran at that longer than I would have thought. To the point where I was like, I just don't feel like this is, I'm not comfortable with this anymore. So I kind of decided to scale back. I went down to 1.24 and 4.5 gigahertz. And we were able to sustain at like 83C.
Okay, that's a little more.
So and I'm comfortable with that.
And that was
that's
with
like a reasonable temperature.
Right.
Wait, you were at 100C on like that dual rad water cooler?
Yeah. Now it spiked up there, and then the fans would spin up and it would cool down, right? But it wasn't running sustained over 100C. It was like 98, but it was close enough.
Still.
I think I actually saw a number like 113 show up once. Now, I don't know how instantaneous that is, right? You know, it's the temperature monitoring stuff through ASUS software.
Listen, the Optane
It's enough to make you go, well, maybe not.
Yeah.
Only the Optane stuff is supposed to do phase change, not the CPUs.
Yeah. So long story short on this general performance, single-threaded performance is better. So let's take gaming out of it. Everything else, like if you look at this Audacity benchmark, that's pretty impressive because the single-threaded performance of this 10-core part now matches the single-threaded performance of the 7700K because of those clock speed changes we saw.
Yep.
Right? But when you look at...
wait, is the IPC basically the same, like clock for clock compared to Kaby Lake?
It's a tiny bit...
Like a % or two or something,
yeah,
probably.
like almost nothing.
Okay.
Yeah. Actually, it may actually be nothing.
Yeah.
No, I think.
Well, I mean, you might get some gains just because there's more cache.
If you look at, say, like one of the, so here's another version, right? It's Cinebench single-threaded. The 7900X at 10 cores is now matching the 7700K. It's a little bit higher. But when you look at multi-threading, it still has this advantage over the previous 10-core as well. So, again, taking the 1080p gaming stuff out of it, this seems to be the instance where Intel actually did what they wanted to do last generation, which was provide like one processor that was the best single-threaded performance you could get and the best multi-threaded performance you could get, right? So
at the same time.
At the same time, right? And so it depends on what your workloads are and all that type of stuff. But it works really well, again, outside of that one use case.
It's looking like the 10-core will probably end up being kind of that sweet spot there.
I don't know. Like, what I'm curious is when we get
12 and 14 cores, like now you're getting to the point where you're just making so much heat.
But keep in mind, they could easily do the same single core up to the same frequency.
For sure.
If it's single core, right?
The single core, yeah, but I don't think you're going to get like, 4.6 gigahertz on all cores on an 18 core.
Overclocking wise, no, I wouldn't think so. I wouldn't think so.
And
but it might still be it's still going to be better stock multi-threaded performance. That's what I'm interested in. Will they be able to maintain that, hey, this is the best single-threaded performance you can get and the best multi-threaded performance you could get as you go up to 12, 14, 16, 18.
It'd be interesting to see if they can
be able to scale in that way.
I'd like to see if they can somehow, if you took the 18-core part and the 10-core part and had them side by side, and you ran a 10-thread or a 10-core workload or whatever.
Yeah.
Right? Like, would both parts be equal? Or would the 18-core part actually be slower because its clocks were,
I don't know.
Interesting.
The caveat to all this is power.
Yeah.
Both these parts are supposed to be 140 watt TDPs.
Okay.
The 6950X, this is running Cinebench 15, multi-threaded workload. The new part draws more than 70 watts extra power, and nobody can tell me why yet. ASUS doesn't know why, but they swear they're not doing anything to affect
over its
voltages.
TDP?
No, over the 6950X.
Oh.
The 7900X draws 70 watts more than 70 watts extra over the previous generation part.
But what's it rated at, is my question.
They're rated at the same TDP.
Which is what number?
140. This is a total system power. You're not looking at...
Oh. Well,
so just note the delta between the two.
I don't think the motherboard just drew an extra 70 watts.
Well, the 7900X is at a higher clock, isn't it?
It's at a higher clock, yes. And so in theory, they're pushing more voltage through the die to get...
Oh, sure, but
that's a significant difference. And Intel has come to me, and I showed all these numbers to Intel, and they're like, that's not what we're seeing. And I'm like, well, what am I doing wrong? Like, I'm using the motherboard that you provided me for testing, and every other reviewer that I see that tested power this way sees the same thing, even those reviews that leaked out early.
Yeah.
Right? They see the same, like, 70 to 80 watts additional power. So... it's possible that maybe like a BIOS fix or something, and like there's just something in there where it's drawing more power than it needs to get to those clock speeds for that long or something. I don't know. But that's a lot. It's a lot. So we've got performance per dollar. You know, it's $1,000 part, so it's going to be hard to justify it. But again, if you look at something like compared to the last generation $1,700 CPU, you'll see it's more than double the performance per dollar in single-threaded. It's almost double the performance per dollar in multi-threaded. That's pretty good, right? Yeah. Despite the fact that we don't know what Threadripper is going to be and we don't know what its performance per dollar is going to look like. Intel has improved things on this generation in terms of performance and price scalability. So that was an incredibly long discussion, almost a monologue about the 7900X. Does anybody have any questions to put to me?
When are they available?
June 26th.
I think it might be exactly what we expected from this launch.
I'm more surprised that the single-threaded performance is that much better. I would say that because there's an 800 megahertz delta between Broadwell E and Skylake-X on single-threaded performance. Yeah. And so that I think is impressive, that they were able to kind of tweak it in enough ways to get that to happen. But yeah, otherwise, like the multi-threaded stuff it makes sense. The boost you see there makes sense. You know, we've known about the pricing and all that for a while. We have a Skylake-X part in. We're going to test that. We'll talk about it next week or the week after, probably next week. So I'm not going to dive into any of that stuff today, but and we'll talk more about the platform once we get a little bit more time under us with that too. So
the next couple months are going to be really interesting.
You're not going in through that.
The next couple months will be very interesting.
Oh yeah. Threadripper is going to come out, and it's going to be at some performance level and some price, and Intel's going to either look really bad again or look okay. And I just have no idea.
Yeah.
I just don't know. It all depends on, like, you can guesstimate the pricing or the performance rather.
Mm-hmm. You can probably guesstimate the pricing.
Well, you can, but you know, the difference of $1,300 for the highest core part versus $800 for the highest core part is significant. And then you got to measure all the other workloads because IPC is still going to go to Intel, right? Yeah. Like nothing is changing fundamentally about either of these things. So we'll see how big of a splash Lisa wants to make with these parts. How far do you go down that rabbit hole? So check out the review.
Make it up in volume.
Yeah.
Make it up.
Yeah. We're selling these at a loss. Make it up in volume. So okay. Damn it, that was a lot of stuff, so I apologize. But hey, speaking of processors, AMD EPYC, probably
never heard of it.
Probably the best / worst name for a product.
Unfortunately, it's growing on me, which is the worst because it's an awful name.
At the presentations I was at, I bet I heard...
Were there a lot of puns?
Probably at least 10 from AMD or partners. We're ready for an EPYC launch. Yeah.
You know, when we thought Athlon was bad back in the day, who in the hell calls a CPU Athlon? What the hell does that even mean?
Athlon just sounded like you had a lisp all the time. That's what that was. So really quickly, we talked about EPYC for a while too, and what its capabilities were. Now we know it's the AMD EPYC 7000 series. They've got model numbers, 32 cores, 8 gigs or 8 channels of DDR4 memory, up to 2 terabytes of memory per CPU. Because you have 16 DIMMs per socket. Jesus. Right? I saw a motherboard with 2 sockets and 32 DIMMs. And it's you can literally not put anything else.
Of DIMMs.
Yeah, it was hilarious looking. 128 lanes of PCIe per processor. And we've talked a lot about that. So the clock speeds are interesting, right? So if you look at the top end part, the 7601, it's like a $4,200 CPU. Keep in mind, guys, we're talking about server and data center on this. Base clock of 2.2, boost clock of 3.2. So a pretty big wide jump there. Obviously not as high as the 8 core that gets up to 4 gigahertz or anything like that, but still pretty impressive for 32 cores on one socket.
I'm just picturing the sheer number of pins just for 8 channels of DDR.
This package is what?
4096?
It's over 4,000 pins. And the socket is enormous, and yeah.
Well, there was pictures of was Lisa holding up the CPU, and it's like as big as her freaking hand is.
Yeah. So I'm not going to run through the specs. You can read the table for yourself. So they're doing comparisons to Broadwell E based Xeon parts, anywhere from 47% to 70% faster. comparing like similar price point parts. So the greater than $4,000 EPYC part versus the greater than $4,000 Xeon part. The Xeon 2699 V4. If you don't follow the Xeon product line, which is incredibly complex, these numbers may or may not make any sense. It's worth
Xeon
noting,
numbering is a mess in itself.
Don't worry, they're going to be called Xeon Platinum soon.
Yeah, I know.
So,
great.
It doesn't matter. They still have the same 4-digit numbers to go along with it.
do they?
Yeah. The important thing here is the performance metrics that AMD showed were spec int and spec FP. It's literally the only performance data we got. Now, those are important synthetic numbers for server and data center workloads.
Yeah.
Right? But we do not yet know exactly in real-world testing what the differences are going to be. Right? You know, AMD had a lot of partners come up. They had HP, they had Dell, you know, they had Supermicro, they had software guys, they had Microsoft from Azure come up there and talk about them using that stuff. So they have a significant amount of partner support up front. So their rollout on this is single socket and 2-socket. They have specific 1-socket processors, and there's a significant push with this idea because apparently I didn't know this about the enterprise market, but there's a ton of 2P servers that exist with just 1 socket filled because they're doing storage on it, or they're doing some other like GPU compute on it, and they don't need the other processing power. They don't need the extra memory channels. And AMD has built a significantly better part for this particular thing, right? So targeting 1 socket, but you don't lose memory channels. Well, you do lose because if you're a 2-socket, you've got 16 channels essentially, but you get 8 full channels, but you don't lose any PCIe. If you have a 2-socket Xeon motherboard, half those PCI Express slots are coming from one processor and half are coming from the other. We see that with our systems when we're working with them out here, right? Depending on which socket you have populated determines which PCIe slots.
And how is it for the other architecture then?
This is 128 lanes of PCIe, whether or not it's a 1-socket system or a 2-socket system.
Oh, because if it's a 2-socket, then half of the lanes are just to communicate with the other CPU.
Yeah. Huh. So you don't lose any PCIe. We saw...
But you don't gain any as well.
Right.
Correct. Yeah.
So if 128 isn't enough, you don't have the possibility.
Well,
which, I mean, 128 is a ridiculous number that could only possibly be enough.
On a 2-socket system for Xeon, you're currently limited to 40 plus 40. So you get 80.
Yeah, but they have 4-socket Xeons.
They do, yes.
With
but we're talking about the 2-socket. Because when you get 4 sockets in a system, you're not putting PCI Express devices in that, right?
Not really.
Not normally, I guess I would say. It's...
And if you're looking for that kind of compute density, you're going to be moving to a blade server anyway.
As opposed to going quad.
Yeah, maybe.
Yeah.
If you need that much, that much I/O, it's probably a task that can be parallel.
So I'm going to scroll on this. I saw this demo of a storage configuration with a 1-socket server. It had 24 NVMe SSDs in by4 PCIe 3.0. So it was using 96. Is that right? Yeah, 96 lanes of PCI Express.
Yep.
Using software RAID.
Yeah.
Right. Some kind of software-defined storage.
Linux distro.
Yeah, because it was FIO was the benchmark that they were running.
Yeah.
9 million IOPS read, 7.1 million IOPS write, and up to 53.3 gigabytes per second of bandwidth on this. Yeah. And he was like, and I got 32 lanes of PCI Express left. If I want to put in if you want to put in 2 MI25, Radeon Instinct compute cards,
which can use that, which can use all of that memory.
Yeah.
I mean, with that many IOPS, you're running into you're running out of CPU power for.
Actually, here's the answer for that. Under the max IOPS, they were on their 7601 32-core processor. They're about 75% CPU utilization.
Yeah.
Right.
So if they use the rest of those
under max bandwidth, they're at about 50% utilization. Because there's 4K versus 128K, so there's less CPU load at the 128.
It should be even lower than that for sequential.
That's what I was told. So they had a 76.8 terabyte NVMe RAID array running at those performance levels.
So cheap too. That's the weird part.
Yeah.
So it's funny when you get into configurations like that, the processor is such an insignificant portion of the cost of the system.
That's true.
Right?
The processor is just a traffic cop at that point.
Yeah.
If you're doing a storage server.
Right. But like the way Xeon differentiates their products, like the cheaper parts don't have the PCIe lanes. They don't have the security features. They don't have some of that stuff. AMD was very upfront about like every EPYC processor will have the same 8 channels of DDR. It will have the same 128 lanes of PCIe. It would have the same security features.
Really?
All the way down the stack.
Down to how many cores? Like
down to 8.
Down to just an 8
They have
core?
an 8-core part, which is an interesting discussion because if you look at, we didn't really learn a whole lot about Infinity Fabric, but they did give us some bandwidth numbers about, like, so a 32-core, well, all EPYC processors are 4 dies. Right, so the 32 cores.
2 on the 8-core ones?
Yes.
2 per die.
So what they've done is, in order to get their yields extremely high, basically an 8-core processor has 2. This is even more. They have 1 core per CCX operating.
That's brilliant.
So there's a potential because that means literally every single
single
thread-to-thread communication has to go through its L3.
Unless it's a hyper thread or
Yeah, correct.
Yeah.
Unless it's part of the SMT.
Yeah.
But for certain operations, that's fine.
But it's
Depending
interesting,
what you're
like,
doing.
servers wouldn't typically need to bounce core to core, like for server, like
yeah.
you know what I mean?
Servers are usually inherently parallelizable.
Yeah.
Yeah.
Okay.
Like each thing is each thread is going to be doing, each core is going to be doing its own thing.
Yeah.
And not having to interact really with other cores.
Because I mean, if you think about it, like
you're not gaming on a server.
An 8-core processor in this platform is really just it is the literal traffic cop, right? And I am only there to provide you PCIe lanes and all that, because it's interesting because that's how they can do that, because all 4 die are active. Even on the 8-core part, it still has 8 channels of DDR memory. It still has 128 lanes of PCIe because it's getting
is the
2
PCI,
from each die.
Does the PCI and the DDR both come in via the fabric? Is that what happens?
No. Each die has its own 2-channel memory controller and 32
and then some of
32
the
lanes of PCIe.
Okay.
Right.
Okay.
So all of that is still active, even if you only have 1 CCX or 1 core per CCX enabled.
The thing is, your scheduler kind of needs to be aware of that.
Yeah,
so that it puts the tasks on the correct, because the
memory is coming from the right memory controller.
Yeah. Well, NUMA is one thing, which is make sure the thread is on the CPU that's connected to the memory. That's NUMA. But like, I could be forgetting something, but like, I don't know of schedulers being aware of, oh wait, that thread needs to talk to this PCI device, so I'll put it on that CPU.
Yeah, that's true. I don't know. I
don't know the answer
to
of that for, like, because Xeons do that, right? Because they split the PCI between cores, but I think your software would have to be a little more aware of the architecture to fully take advantage of it.
So
well, it seems like it's all going to be addresses and NUMA with PCIe.
Yeah.
I mean, not so much NUMA, but you're going to have addresses for each device. And so it's just going to route it to the correct controller.
The CPU is going to know what to do with that.
Right.
Yeah.
It just the concern is you don't
level. So
you just don't want the wrong CPU trying to talk to the PCI device that's hanging off.
Well, it's not going to do that because it's got addresses.
Yeah. I'm with you.
Okay. Now, what's interesting is, so these are questions we had coming into this, and this answers our questions for Threadripper as well. I should note, for Threadripper, I don't yet know if it's the same substrate with 4 die,
like
and now we're looking at 2 cores per CCX. That's probably the most likely solution for Threadripper.
I'm pretty sure.
Or is it 2 die?
I'm pretty sure we know it's 2 die.
Do we?
Yeah, I would think Threadripper would be half of that.
Honestly, we're so far in at this point, I don't know if that's just the
if somebody in the chat,
speculation or confirmed, but I'm pretty sure
it could be either.
It could be either.
Yeah.
Right?
It could be, because depending on if you've got some... it just depends on yields and bins of parts, and they throw it into different areas and say, hey, this is appropriate for this, or this. You can go ahead and integrate them because they use the same socket in between Threadripper and EPYC. It
seems to me.
Go ahead.
It seems to me unlikely that they would want to like validate another package and all that stuff, right? Like,
well, I mean, if you only had 2 possible packages,
if you make a 4 die version and a 2 die version, if I were to guess, I honestly have no idea at this point. I'm going to guess that it's a 4 die, 2 per CCX. Well, actually, no, because that wouldn't make as much sense because it has half the memory channels and half the PCIe.
And half the PCIe.
So maybe it is just 2 die.
Yeah.
I think that's probably most likely. But we're saying that in terms of flexibility, they could do either. But if you got a 4 die one, you've got to start disabling a lot of stuff.
Well, I mean, they sell 16 core versions of EPYC, right? And it is a 4 die thing. But this slide shows the like die-to-die bandwidth is 42 gigabytes per second bidirectional. They go into the power stuff, 2 picojoules per bit TDP, right? Just talking about how much power, low power this is supposed to be. When you go to socket in a 2-socket, this is kind of interesting. There are 4 links between the 2 processors from die to die, like I don't know if it's exactly mapped like this, but it looks like it on this diagram. The top left die is mapped to the top left die of the other socket.
Yeah, it's as if you laid them on top of each other.
Yeah. And that bidirectional bandwidth is 38 gigabytes per second, which means you have at most 2 hops to get to any other core.
Yeah.
Right? You go across to the other socket and then, your jump across those die in there. And then they go into the PCIe breakdown and that type of stuff. You can literally get down to, you could bifurcate the bi-16 connections, which there are 2 per die, down to 16 by 1s per.
Meaning you can have
you could have 64 by 1s. Is that what that says?
No, it's saying bifurcation of 8 PCI devices per X16. So wouldn't that be an X2?
Yeah.
Yeah.
It's saying there are 8 bi-16 links, right? 2 from each die.
Max of 8 PCI.
It's a sub-note.
Oh,
max of 8 PCI
yes,
devices.
Okay, you're right. So you could have maximum of 8 per. Yeah, so you could do 32.
But their drawing is a little confusing there because it does break it all the way down into. It breaks it down into 16 by 1s.
It does in the diagram. It does, doesn't it? Okay.
Yeah.
Yeah, I don't know.
Yeah, I don't know.
I'll have to get clarification from that. So this is the diagram that shows all the bandwidths together, and also note that there's no chipset for this, right? USB is built into the die, and the SoC SATA is built into the die.
The quote unquote X300 that we've never seen.
I guess.
Like they have to have something doing timers and
you got to have
and
some
stuff
physical
like that.
layers. For this stuff.
Yeah, I guess.
But for X300, that was just a simple chip communicating over serial SPI.
I don't think I have anything in there for that slide, but yeah.
So you know what I think they're trying to say there on that, because on the bottom section of the drawing, they're showing that's still confusing.
It's confusing. Here's the thing about not having a South bridge. You've got all the USB you'd probably need for a server.
Yeah.
And anybody who's going to do anything on a server is going to have a RAID card.
Slots.
Or some kind of NVMe thing.
You need slots.
Yeah.
Honestly, with this,
you're going to have plenty of slots.
With this architecture and how many cores you have and how many lanes you have, the RAID card is almost like irrelevant unless you need to do SATA specifically.
Which a lot of people are still doing.
That's
for
true.
Massive storage.
I mean, you'd love some of these servers I saw, Allyn. Like Supermicro had a bare bones, and I don't even know the connection they're using is an NVMe connection to like backplanes.
Yeah. Supermicro has like a whole tray that like pivots up, and you can just slide a bunch of drives in.
And so there's like, this is the 24 drive.
Yeah.
2U version of this.
Yeah. Supermicro was making those servers, and they had to use a bunch of PCIe switches to be able to fan out.
They don't have to do that anymore.
They don't have to do that anymore. They just route all the lanes, and so instead, it makes for a cheaper server as well.
Man, server shit is so cool.
It's incredibly neat, and
it can be.
There's a lot of stuff. There's a lot of stuff that we didn't go over here, like about security and manageability and RAS, which is reliability, accessibility and security. Yeah. RAS features they kept talking about. It took me a little bit to wrap my head around. But it's an impressive launch for them. When did Opteron launch, Josh? 2003, I think.
It was around there, right?
2003, 2004.
I remember being at the Opteron launch and how significant of a thing it was for AMD at the time. And this felt very similar, right? And they know, I got to talk with Lisa, I got to talk with Forrest, who's the VP in charge of it, and they know that it's an uphill battle. Like they have to reconvince these people to buy into their ecosystem. But there's literally nowhere for them to go but up.
Yeah.
When your market share rounds to 0, which it does.
Yeah.
It doesn't round to 1, it rounds to 0.
Nowhere to go.
And this is what they told me.
Nowhere to go but up. And if you have products that are undercutting Xeons on cost and have just an insane amount of connectivity.
You almost feel bad for Intel, like there's Xeon PMs, not like the executives, because they're still going to make money, but like if you're a Xeon PM, you literally cannot win in this next year, you're going to lose market share.
Yeah.
You're going to lose, margin.
As it turns out, when you're at 99% of the market, you have to decrease some.
This is why they do drones, and
I don't even know what I don't even know what their product manager's counter would be to like the person that's like, well, but I was thinking of buying this EPYC thing. Like, what are you going to counter?
It's discounts. It's we have the best ecosystem. We have the best software ecosystem.
The thread performance is a little bit faster, but
I mean, it's going to be faster. The IPC is going to be faster.
Better IPC.
AMD was very upfront about like. Now I need to get this one correct. They're much more about scale out workloads than scale up workloads.
Yeah.
Right. So things that can fill out memory, things that can fill out connectivity.
Yep.
Giant database servers, that type of stuff. Where if you can get 32 DIMMs and you can get 4 terabytes of memory in one rack, that's a huge benefit.
Yeah. And just an insane amount of like
density
with a $4,000 processor.
Insane amount of flash hooked up to it for without crazy PCIe switching and all sorts of like
external connectivity.
Yeah,
out of the box connectivity.
Supermicro's like largest chassis is like 2 layers nested worth of PCI switches. Nice. Because the first switch can't fan out enough to get to all the slots.
Sweet.
So they had to put another set of. So it's like literally making a tree off of the Xeon.
Yeah.
Right.
Yeah.
Yeah.
I imagine if you're the CTO of like some big company like Netflix or whatever who is running their own data servers, so depending on AWS now, you're just looking at these bills from Dell or whoever you buy your servers from and just spinning and just like looking at the number, and then someone comes and offers you a cheaper solution, you're definitely going to take them seriously.
That's the point I'm trying to make is the processor itself is not just the cheaper thing. It's the ability, like its capabilities makes the whole platform cheaper.
So like Dropbox was one of the partners that had like a video. They're talking about like, look, we do storage. So massive amounts of storage per device is important. But they said, but we still need good performance because they're doing versioning, they're doing like preview files
deduplication.
Of stuff.
They do like
like they still need some of it, but their density of stuff is there. So
as mentioned,
and obviously front end servers as well, because Baidu is another one of their partners for this,
and they're one of the Super 7. That's a really big
they're
deal
huge
for them,
monstrous. Yeah.
Go ahead, Alex.
Oh, that's good. As I mentioned on IRC, it's also going to make for a really nice virtualization server.
That's true too.
I mean, that's
the only
kind of the thing.
The only question that comes up with virtualization is when you start to virtualize across CCXs.
That's fine.
You wouldn't.
Well, then that limits you to 4-core
instances would be using their own RAM and their own PCI devices.
But then you can never have more than a 4-core VM.
That's fine though. If you
as long as you're fine with that.
That's plenty for if you're trying to have a lot of VMs on a machine, you don't want them all to have a lot of cores.
If you need more than 4 cores on a VM, you're going back to bare metal anyway.
Yeah, typical VMs.
I mean,
think about like VDI applications, and it's actually good because you wouldn't want to hop outside of a CCX. Like you'd have a bunch of dual core machines running off of this 32 core.
Yeah. I think
EPYC, and you wouldn't be copying across the CCX for anything. It'd be like self-contained systems.
As long as you're 4-core or below. Yeah. Yes. But I think there's more instances of greater than 4. Like when you're talking about having 64 cores in one
but not
chassis.
For a VM. Not for a VM. Virtualized servers will
definitely
not have
more
a lot
than
of
4 in a chassis, but not for more than for
each
like,
VM.
depending on what.
So like literally, hold on, but you guys are making sense because if I go to Amazon and try to do a virtualized server, I can get
that's different.
But it's not like that. This is who they're trying to sell to. I can buy 10-core, database servers from Amazon EC2.
Yes, you can,
and that is a virtualized environment, right?
Database
that is for the most demanding workloads.
Database server is scale up.
Well, for whatever you want it to be, right? Like you can get a 10-core server from EC2.
Right. That's what I'm saying. So if you want if you want a bunch of cores, but then again, if you want that, you're going to have the same CCX penalty even if you were on bare metal with the same processor.
Correct. Correct.
So what?
And then there's another inherent latency built in depending on what virtual instancing you use.
Right.
There can be actual built-in delays between cores, regardless of what hardware you're running, which scales up as you go beyond 2 or 4 cores.
Yeah.
So you might actually outweigh the CCX penalty just by the built-in inherent latency of a virtual machine.
Right.
A whole bunch of 4 cores stacked up together is going to be overall more efficient. So it makes sense to me.
Okay.
And the ability to have that many PCIe slots and do something like VDI, desktop replacement, and dedicate a GPU to it. Because like I have a friend who does IT at an architecture firm, and they need GPUs.
Yeah.
And right now they're depending on like NVIDIA grid cards, and they're subdividing the GPUs, whereas they could just dedicate one GPU per user on VDI.
Yeah, you would have your own set of hardware.
PCIe.
Yeah. So
all centralized.
Yeah.
Regardless of the like specific workloads, because trust me, Intel's going to find the specific workloads that this doesn't work, and they're going to talk about it. It's a huge launch for them. They're well aware of like the challenges that talked with Forrest about Zen 2 and Zen 3 and what those architectures are going to be, and why they have to make this pricing argument today, but they don't want to have to sacrifice that going forward. And it's a big deal for AMD. So good for them. What else we got to talk about? Josh, we promised people we would talk a little bit about 5 nanometer stuffs.
Sure we can.
I like this because it was they're pages, right? It's like they're just printing this out of an inkjet or something like that. So
yeah, pretty much. Yeah.
He's wearing gloves. He's wearing gloves, but
Nanosheet.
But that shirt is ESDing the crap out of that wafer. just saying. So
yeah, well,
it's microfiber. He's cleaning it.
Yeah. I don't know why they're doing it, but what it is. So yeah, IBM, we talked about this a little bit a couple of weeks back. They just announced their 5 nanometer breakthrough with silicon nanosheet technology. So essentially FinFETs are gates that are surrounded on 3 sides. And this adds the 4th dimension. So it's surrounded on 4 sides, and they actually lay it down in layers of sheets. So you've got multiple litho layers, deposition, whatnot. And this solves a lot of problems with what FinFETs will be encountering at 7 nanometers and below. So 7 nanometers kind of the last gasp for the traditional FinFET that we saw introduced with 22 nanometer. After that, you can get things smaller, but you're going to have to keep power about the same, and your switching speeds are going to be about the same. And so you're going to increase the density, but you're not going to have any kind of power and performance increase to go along with that. So yeah, you've got a smaller chip, but it's going to have probably more negative characteristics than the chip that was made at a larger node, because you've got more power and more heat dissipated in a smaller area than what you did before. And so IBM has gone ahead and they've worked with Global Foundries, Samsung, SUNY Rochester, is that right? That's one of the reasons why AMD originally set out to build their fabs up there in New York, because they're very close to SUNY Albany and their litho and chip making research center. And that was an area that IBM had worked with for just decades, seemingly. I mean, they had their East Fishkill fabs. Mm-hmm. They worked with SUNY. It's all one big happy family. And now Global Foundries and IBM are working close together, and we've got this. So we've got these multiple layers of nanosheets. It allows us to not only just shrink past the 7 nanometer, and who the hell knows what the actual dimensions are, because it's a lot of marketing involved with these sizes, but because of the unique structure and materials, they're able to kind of keep the advances going in terms of power and clock speed. So you've got in something essentially the size of a fingernail, about 30 billion transistors, which is far more than what is the latest? Is the 1080 Ti? No, it's the Volta, the V100, the new thing from NVIDIA.
Yeah.
That is around 600 nanometer, a millimeter squared, that is 21.3 billion transistors in that.
Yeah, that sounds right. Yeah.
Yeah. And so you've now shrunk that dramatically to about 70 millimeters square and have 30 billion transistors in there. So
sounds all right.
It is a significant jump. And it's something that Intel hasn't shown off, though they're probably working on something like this, but we don't know exactly when this is going to come into play. Some people say some interesting tests could be happening around late 2018, but more than likely we may see some of the first products on this new process technology in late 2019. So it's not exactly around the corner, but then again, it's not exactly 10 years off. So we're still moving forward. We're working around some strange quantum mechanics and physics here.
Yeah.
I'm kind of wondering how they do, like quantum tunneling and fun things like that have already been showing up at 14 nanometers and below. So yeah, they have extended silicon-based chip technology yet again beyond what people had originally thought they would be able to do. So 5 nanometer, it's coming in a couple of years, and it looks like it works.
Huzzah.
I've heard of dental bridges before, but that one just looks nasty.
Yeah.
Bring that picture back. That just looks like the world's worst dental x-ray ever.
That guy had a lot of work done.
Share roots.
It adds strength to the overall collection, I feel. Yeah. Oop, clicked on that one. Where'd we go here?
You broke it all.
Is Chrome just, wow, okay.
Did it crash again on you?
I think it did. Chrome is kicking ass and taking, oh, wait, no, hold on. Nope.
Taking podcasts.
There, okay.
Yeah, I see it.
I'm gonna leave it like that. Yeah, but I can't scroll yet, but I'm gonna go with it for now. So this just went up right before we got to the show going here. Ken did some testing while I was out of the 802.11ad capability of an ASUS X299 motherboard and a Netgear X, what was it?
Nighthawk X10 router,
which is an amazing name. So I'm gonna try to close this and reopen it. Come on, Chrome, you can do it.
And note, this is not 802.1ad.
No, 802.1ad.
No, this is not VLAN.
When I saw the story come across, I was like, what? VLAN's on a what? Oh.
Yeah, no. So 802.11ad, can you explain this? It's WiGig.
Yeah.
It's kind of its marketing name,
Yeah,
I guess,
there's the WiGig Alliance, which is kind of...
I like alliances.
is marketing 802.11ad. That's obviously the name of the standard from IEEE, as you would expect. You know, when you're going through the airport and you're a plebeian and you don't have pre-check or programs like that, you have to go through those machines where you put your hands up and they scan you with millimeter waves.
Yeah.
What if I told you you could have that in your very house?
I like it. I'm a fan.
Yeah. So essentially, 802.11ad is networking over 60 gigahertz, whereas we're used to 2.4 gigahertz with technologies up to 802.11n. Well, and could also operate on the 5 gigahertz range.
Right.
And AC is 5 gigahertz only. This is sort of an entirely new technology running 60 gigahertz or millimeter wavelengths.
Now, it's worth noting, we have seen some WiGig stuff like as dock stations, but it was very specific. You had to have one specific laptop spared with like a specific dock, and it kind of...
Apparently, Dell's been doing this since like 2014-ish, which was interesting. I could find some old posts. Never really anyone posting about like it working or like anything about the experience, just that this was an option offered on high-end Latitude machines.
Right.
But at CES, we saw the TP-Link router announced, which was the first router announced with 802.11ad. And then in the months since then, I think it was February, that this Netgear Nighthawk X10 came out with support for 802.11ad. And the sort of impetus was we got the
X299 motherboard.
Prime X299 Deluxe that has an 802.11ad. I'm just going to call it WiGig from here on.
Sure.
We'll just stick with that.
Or you just call it AD.
Yeah.
You know, you do what you want. You do what you want to do.
Has a WiGig radio built in. So it was sort of the first client that we saw. There has been like one specific Acer laptop that had WiGig in it that people were using for testing, but this is sort of the first mainstream application of it. And I know ASUS announced at least one other X299 motherboard. I think it was the RG motherboard has AD in it. And I think there are a couple other people that announced support. There's one essentially Qualcomm M.2 radio now that people are using that they can just integrate in any of these machines. But we wanted to figure out what it was like.
I've
been reading about 802.11ad WiGig stuff for a long time now. Yeah. It's been up and coming for quite a while. I think they pretty much announced AD along with AC several years ago.
Feels like it, if nothing else.
Yeah.
So we just went out and bought this Netgear router, which this picture, I don't know if it gives you a sense of scale. It's an enormous ass thing.
No, but I posted the one that Ken posted in the Slack chat up to Amateur because you can see it there.
Oh, okay.
You can see how wide insane. Those antennas are.
Yeah, the box it comes in is, I'm trying to think of a good analog. It's like the size of like an Xbox One box. It's gigantic.
Or how about like a Chain Tech video card box, the size of a small briefcase.
Yeah,
that's large. That's a large box for a router.
Allyn was there when I opened the box. And I was like, "What the hell is this?" And it's heavy too. Like it's not a light affair.
So this one also had a 10 gigabit.
Yes. So it has
wired connection.
Yes. So the difference between the Netgear and the TP-Link, at least from the outset, we haven't tested both of them. They're both using the same AD chipset on the radio side, but the Netgear router has a 10 gig switch port, which is very important because 802.11ad is capable of up to 4.6 gigabits per second.
Right.
So if you're trying to run benchmarks from another computer that
even if you're actually
on
using
a 1 gig port,
yeah,
I mean, you could still do AD to AD at full speed with the TP-Link in theory, but if you want to do wired to wireless, you would need a 10 gig port.
And Jim actually had this switch here handy, which worked out well for us. And it's interesting. It's not using Ethernet. It's using
SFP
Plus, which is an optical cable essentially.
No, I've been corrected on that.
Oh, I see.
No, well, the transport's whatever you want it to be, but it's an electrical connection on the port.
Okay.
And the transceiver's in the actual connector ends.
Yeah. Oh, okay.
Yeah. So it's still copper ultimately, but.
So you did some testing on it. We were just basically like, okay, what does this actually get you? And these were the results you got, which were interesting. So it's important to note that millimeter wave has
a lot of inherent.
It has an issue.
Yeah.
It has an issue of range, we'll call it.
And not only that, but you can put a piece of paper in front of it.
See, I was going to make a lewd joke.
Block the signal.
I was going to do a lewd joke, and Josh ruined it, and that seems counterintuitive to me.
Even
I was going to say
makes no sense.
802.11ad had a problem with penetration.
Has a problem with the D.
And that it can't get through anything.
We were able to go from full signal to unable to connect by me rotating the router by 30 degrees.
Yeah. It's a very, very particular thing.
So it's not bi-directional.
So you know what?
I think it's down to like
when you're laying on top of it, it's second to none. It's magical.
So I mean, if you look at these results, we don't get close to the 4.6 gigabits.
No, which I mean, you've never been able to get close to any of the wireless ratings. Like this,
because AC was supposed to go up to like 1300 megabits.
Yeah, and
we only ever
supposed to include both directions at the same time as well.
Maybe multiple devices as well.
So do you think it's a bad thing that it's got directions that say, "Hey, girl, if you want full bandwidth, you better lay on top"?
Yeah, no,
damn it,
I don't.
Come on.
So I mean, so at 0 feet, you basically had the router sitting next to the machine.
No, I had the external antenna on the motherboard on top of the router,
like in between all the antennas.
I put the external antenna from the motherboard in the middle of the router, and that was 0 feet. So that's when I got my max throughput of about 2.2 gigabits per second.
It's good.
Moving it a more reasonable distance away, where I had them both sitting on the desk about 2 or 3 feet apart, I got almost 1.9 gigabits per second.
Yeah.
And then we took it to an even more reasonable scenario where I kind of put the router on a movable cart and I pushed it away. And we're about 15 feet away. And we got just under 1.7 gigabits per second.
Yeah.
And then we started to test the limits of this large single room we have. So as we alluded to, 802.11 AD will not go through walls. So we have this big open area here we use for the studio and our office. So it was kind of a handy place to test. And then as you can see from the results, at about, we'll say 15 feet plus, it dropped to 700 megabits.
So so this is very like situation dependent if this would be beneficial. But like
we had at least partial line of sight all of the time. We weren't totally occluding.
Yeah.
So like if in our environment, people on the stream can't see this, but if we put that router where that printer is, it would address your machine, my machine, Ken's machines, and probably Alex's machine.
But if you were on the far end of the office,
you wouldn't. It would be no benefit. But what's important to note is like he has the 802.11 AC results from this router there as well.
Yeah,
and it was always faster than that.
Yeah.
Yep.
And the AC was extremely consistent. You know what to expect, and you can only expect about 700 megabits out of that motherboard and that router and the configuration we had set up.
Sure, and there may be faster AC configurations with different controllers and whatnot.
Sure.
Yeah.
So can I ask a serious question?
I'm actually not sure you can. Yeah.
No, it really is a serious question. So, okay, I'm connected to this thing, and I'm on my laptop, and I've got my antenna. Allyn walks in front of it slowly. Will you lose connection? Will you see drops? Are you just out of luck?
So Allyn and I were testing it. I had him over at the computer, and I was with the router. And, I mean, we're still walking around the office. I didn't necessarily stand exactly in the middle of it, but we didn't really see any drops in that scenario. Even though we are bags of water, I don't think it necessarily affects it that much.
Bags of mostly water.
I feel like it can mostly go around you at that point. It's bouncing off and sort of figuring out a path as long as you start with mostly line of sight in that scenario.
So, the router's $500 almost, $450. So that's pretty pricey. The motherboard is $450 that has 802.11 AD built into it. So this is an expensive combination if you happen to dive down that rabbit hole. It was more of a experiment of, hey, this is our first time messing with it. It's also very possible that we get, this is very new.
It's very first gen stuff.
Like Netgear updates its firmware, ASUS updates the drivers or firmware.
And actually, we were doing some testing, and then Allyn was like, "Well, did you update the firmware on the router?" And I hadn't yet, and I updated it, and the testing was a little bit better.
Yeah.
So
I would expect that to be the kind of the case for
because it was doing like it shouldn't just drop if you rotate the router a little bit. Like that's.
Well, I don't know how directional the antenna.
And I don't necessarily know where the 60 gig antenna was on the device because you see the 4 external antennas, but those are mostly probably just for MIMO 5 gigahertz stuff. I don't know exactly the configuration of any of that stuff, but mostly in the short little article I posted, I came to the conclusion that we're probably never going to see wide stream adoption of AD for general networking stuff, even for computer to computer operations. We're going to see it for stuff like wireless notebook docks and VR headsets. Intel at E3 was showing off a Vive with the WiGig adapter, and people said it was great from the personal experience. It's that sort of high bandwidth, low range, line of sight stuff that it's cool for. I mean, we were postulating in the office where if you had like your gaming PC and you wanted to sort of do a wireless display to your 4K TV, that could be an interesting option as long as you had sort of line of sight, which I think for a decent amount of people you might, where you don't want to run a 20-foot HDMI cord, but you can still see each other from the scenario.
Yeah, I think it's pretty interesting. I wouldn't buy into it yet. Definitely not. But pretty cool. Expensive.
I mean, you can afford like an 8-port 10 gig switch and a couple of 10 gig NICs. For
the $450, but then you got
for what you need on both ends for $1,000.
The truth is, wires suck. Right now, wireless sucks more than wires, but wires still suck. So if we could get,
enough gaff tape will make wires fine.
Make wires.
I mean, yes, you are looking. If it's like you're looking in our office right
crappy
now,
going across the ceiling of your dining room, but it's going to be fine.
It's fine. You can still get Netflix, right?
Yeah.
That's what's important.
One last story before we get to our picks here. iFixit, Microsoft Surface laptop. I think it's the worst score they've ever given a product.
If we could give it a -1, we would have.
That's what they say. Really?
I mean, they could have.
That is what they said.
What makes it so bad?
Can't.
Everything is glued and soldered.
Yeah, you can't open anything.
Okay.
Can't, you know.
And what was like? So that's different than significantly different than the Surface tablet.
What happened with the last one?
No,
where
was the
the
Surface tablet?
I mean, the Surface tablet is glued together, but at least the components are socketed. So if you do get it apart, you can change stuff.
Wasn't there
You're not getting it apart, but
like the previous generation one? There was a guy that took a Dremel and a die cutter bit.
to the back of the Surface Pro 4.
And he cut a freaking square where the M.2 SSD was.
To upgrade memory.
He took the lid off and he can just swap out his SSD.
Yeah.
That's probably not great.
And then he I
option.
don't know how he put the thing back on, and he just like put a piece of tape over it.
I still want to try one of these laptops. Like that.
Oh yeah, I mean, I think they're a fine device, and in the scenario where the machine is glued together anyways, I don't necessarily think socketed components are an important detail because you would have to be like that Surface Pro 4 guy who is extremely invasive in his machine to upgrade the hardware, but it still sucks to not have the opportunity. Even this stupid MacBook with the touch bar got a 2 out of 10.
Yeah, okay.
And like this has a solid SSD
so
and
the
everything,
iPad,
but it has screws on the bottom. They might be pencil lip screws, but they're screws, damn it.
Yeah.
Oh.
So yeah, you pop a key off of that keyboard and, guess you better buy a new one.
All right, before we get to our picks of the week, we're going to do a... Oh my God, Chrome, what is your deal? We were...
Should just switch to Edge. Microsoft or Windows 10 keeps telling me to.
I might. So we're going to do a non-visual check-in with people who have signed on to do the mining thing, the hashing thing. Why? Like, oh, man. Let me see if I can figure this out. There we go. All right, here we go. So I'm going to refresh this and see what happens. So this is like a monitoring thing. So if you guys go to NiceHash and put in that wallet code that we gave you, you can actually see how many people are working. That's listed as workers. I think that's unique per application, right? Like instance of the application running.
You could have multiple workers for one
machine.
For one machine, yes.
Okay. So this is, you guys can keep track of it.
You can scroll down and see what the labels of the machines are, though.
If we've got 7 machines working on it now, so that's pretty awesome. We've got Comrade, DRV001, Fallbyte, Korea, PC Per.
Which ironically isn't us.
That's not us, yeah.
PC Per is not us.
SA 2011, awesome. So it doesn't tell us what hardware they're running. You can maybe guess by looking at the algorithms that are going. So the Dagger Hashimoto's are Radeon cards.
Yeah.
Right, and Equihash. I don't know what that one would be.
What is a sol per second?
It's a solution. Yeah.
Yeah. Solutions.
Oh, solutions. Okay.
So Equihash is an algorithm attached to a couple different currencies. The main one is Zcash, I believe. So that's kind of another up and coming.
Libri. Well, I call it Libri or Library, or I don't know what you would pronounce LBRY, but that's usually running on NVIDIA cards. So my guess is Fallbyte has a GeForce card of some kind running in that system. So it's interesting. Very cool that you guys are doing that. Anybody who wants to do that, again, you can go to pcper.com, look for that story about donating your, what do we call it? Donating
your GPU
horsepower cycles to us. And I think it's pretty cool. I just kind of want to see where are we at? What's our total? Does it give you, I guess, because it's a whole bunch of different currencies, it doesn't give you any kind of like singular speed. It's more about like the Bitcoin per day rate, I guess, but then that changes based on the value of Bitcoin and all that type of stuff. So,
Bitcoin per day doesn't really change based on the value of Bitcoin.
Oh, okay, yeah, it's Bitcoin, not dollars. So, hopefully we can spike that up. So, if you're interested in contributing, you don't want to have to sign up for Patreon or write a check to Josh.
It's like a clicker. We're going to see how high the numbers go.
Want to see how high the numbers go?
Everyone contribute, and we'll see how high we can get the numbers.
Yes, please. Yeah.
And then we're going to sell it all out and see how low we can drive the currency value down.
I tell you what.
I think we could sign on people up for getting a run on Bitcoin.
Trust me, I would sell well before $30 million of currency would pile up in any single given account. I am quite confident in that. So.
Also, I don't think we'll be doing this job anymore.
We might be Allyn, but he won't be.
Yeah, he won't. Yeah. He'll be in the Bahamas.
I'll be gone. I mean, I'll just like set up a tent outside on the lawn with like a fan and just relax all day.
Just sit out.
Like, hey,
please, you'll be living in Disneyland.
What are you guys doing in there?
Permanently.
Is it warm from the machines that are still running?
So warm. Please, sir, can I have a fan?
All right. Hardware, software picks of the week. Mine is interesting in that I think I talked last week about getting an iPad Pro keyboard, the pencil, all that type of stuff, and messing around with it. And I'm trying to do this experiment of like actually trying to use it as my productivity device. Yep. So that means doing writing, doing news posts. First thing I notice is the website WYSIWYG editor and iOS based browsers do not play nice. If you go into the HTML version of it, everything's fine.
Yeah.
But if you want to use the WYSIWYG version, the WYSIWYG version, it sucks. That being said, I installed Microsoft Word, which is free on iOS. Interestingly, like completely. It is. All the Microsoft Office apps.
Remember Microsoft Works?
Free for 30 days.
It's a trial.
Wait, really?
Yeah.
Otherwise, you need Office 365.
Oh, okay. So I do have an Office 365 subscription.
That's why it's free.
Oh, okay. So it's not free. Never mind. I'm still paying for it. I will say I was surprised by how well
it's a good app.
It works.
Yeah.
There are some limitations to it in terms of more surrounding like local file storage and how you kind of do that stuff. Also, I use Dropbox a lot for my workflow.
You can open the files directly in Word.
You can open them, but the problem is they're not saved locally. So I had this problem where I was on a plane and the internet wasn't working, so I couldn't open a file to write.
Yeah, you have to have already had it open.
Yes, and Yes.
Yeah.
Even if you go back to the menu or you go back to the home screen of it and it saves, it re-uploads the files when you do that, like to keep things in sync. Even if you want to open it up again to look at it, I wasn't able to do that. So I don't think that's really a restriction of the app itself. It's more of the platform that it's on. So I'm curious if like iOS 11 changes any of that.
It might with the files thing.
With the files stuff, I don't know how. Maybe I think Dropbox will still be problematic because you're not going to install Dropbox. Not going to have root access to the file system to be able to sync documents. Would be my guess. If they can figure it out, I think that's awesome. But it worked well. There's some like formatting discrepancies. I would say if you're trying to like put a link, a hyperlink into on a piece of text, highlighting something with your finger still sucks as opposed to using a mouse and keyboard. But I was more impressed than I kind of expected to be. Also, one of the things I couldn't do, so this allows you to export as a PDF, which I was doing a proposal for somebody and I wanted to export a Word doc as a PDF. Yep. And it does support it. And I uploaded that to Dropbox. However, as far as I could find, there was no way to attach said PDF that I created to an email to send out to somebody.
You want to attach something from Dropbox?
Yeah.
To an email?
Or even like let me go to Dropbox and save that PDF locally to then
No, it gets pissed off unless you're doing OneDrive.
You can't.
Or SharePoint.
Well, even that's inside Word. I'm just trying to I'm in Gmail now trying to attach this document.
Yeah, it's going to get pissy.
I think you can do it, but you have to sort of start from the attachment. You have to say email this attachment and then write the message around it, which is totally a natural workflow.
But if you're opening up the file through Dropbox?
You have to use a different email app.
You have to use the mail app.
No.
Either the mail app
after the shit Gmail's been giving me, maybe that's a good idea.
I use, Spark. Spark will do it.
Spark.
So the Files app in iOS 11 is sort of their answer to all of this stuff, where you'll be able to mount your Dropbox and all of these different services and drag files over to other apps, which is...
Okay. Oh my God! Who would have thought of such a thing?
Drag files from apps to apps.
It's like cloud storage or something.
Even though they haven't added Dropbox to the list yet.
I mean, it's a beta. Like Dropbox will probably have to integrate with the app. But, I mean, it's still in beta.
Yeah. All right, so that's me. Jeremy, what do you got?
All right, so this is kind of a nifty new controller that I just spotted this week. That it looks exactly like something that you should be using if you're, say, Alex and trying to run the board here. But the thing is, it will also install as a mouse or a gamepad and just let you map every single one of these buttons, switches, or dials to a certain function in any program. It's keystroke or turn or whatever.
Can I do record scratches?
You can.
I want to do record scratches.
And you should use a virtual record so you can practice enough to get good. But the thing is that, as you can see...
There's no getting good.
As it mentions there, the module is attached magnetically. So if you click on some of the other pictures, it looks like building blocks because it is. You snap this thing together in however the hell you want. Make it into a little arcade simulator, run audio off of it, map the dial to your sniper rifle so that you can zoom in and out very easily. It's a little bit on the expensive side. Like the base kit we're looking at here is $300, but it's damn nifty. So if you're building a MIDI box, or if you just really want to prove you can beat Dark Souls with 2 dials, this is your thing.
Don't think you can do that.
No, it's
some guy beat it with like a Guitar Hero.
I was gonna say the challenge is always the Guitar Hero controller.
Oh man, that's pretty impressive. All right.
But it's a little expensive, but it's freaking nifty. And if like, how much did you guys pay for some of the equivalent stuff you're using hardware wise?
On those audio boxes or more, yeah.
I bet you it was more than the $300.
Yeah.
Usually.
All right,
give it a look,
Josh.
Me.
You.
It's all about me, as it should be. And why wouldn't it?
Yes, great.
Okay, so, a couple of months ago, I talked about the My Digital SSD stuff. The NVMe was the least expensive, 500 gig. Probably, no, it's 480 gig of NVMe. Well, you know what? Those got so popular, they've blown up to $250 for a 500 gigger. And so now, oddly enough, Samsung, who's got their own fabs and whatnot, and are producing this 3D memory NAND stuff, whatever it's called. What's it called, Alan?
VNAND.
Whatever. Anyway, you can get the 500 gig for $219. It's so much cheaper.
It's pretty good
than anything else. Finally, they've dropped in price.
Is that 10 cents?
And you can get. What's that?
I bought one of these drives of the weekend at Micro Center, and I think it was like a weekend sale, and it was $210. So I mean, $220 at any point is pretty damn good.
Yeah,
I was amazed that you could get that level of performance and capacity for $210.
Yeah, it's a deal if you could use it. And let me tell you, I can use it.
Yeah, it's a great drive.
Yeah,
very cool. Let's see. I'm gonna try. Nope. Holy moly! All right. Let me see. What we got next? Alan, what do you got for me?
So you know how you have some power supplies come with the PCI power connectors, comes with a pair of them off of one cable, but they're like 2 inches apart.
Yeah.
Well, spend like a couple bucks and just get like a little extension thing.
I wish I could show everybody at home.
Oh, but his browser's broken.
I don't.
So in the show notes, there'll be a link to.
Now, what's separated by 2 inches?
Jacob's parts.
Is that the EVGA spinoff?
Oh Lord!
I think it might be.
Yeah, but just don't go through a bunch of heartache trying to find the specific kind of model cable for your power supply, because those are a big pain. And if you put the wrong one in, you're going to fry your video card.
You could, yeah.
Right. So
don't risk that.
You just get an extension just for the 8-pin that just connects into 8-pin female versus 8-pin male. Just like
that's true,
right? And you look around eBay, Amazon, they're like $2 or $3 a pop. Easy.
Trust me, it looks amazing, guys. I won't show it, but
yeah,
it's just there.
Yeah, we'll fix it.
2 inches.
I mean, that one's the one I found was where the heck is it?
Oh no, this is 8 inches, Josh.
This is
serious.
That's too many inches, Jeremy.
That's too many. It might be too many inches of an extension, but
that's too many.
Yeah, so it's just
it like circles back around.
Yeah, it's just some cable, a couple 8-pin connectors there.
Oh man, All right, Alan, Alex, or Ken, Alex, you didn't have anything on the list here today, right? Okay. So that's going to be it for the show. I do want to say, while we were closing up here, I did, for people who were trying to find that link, and I just kept saying, go to the homepage and search for this, I just created a custom URL. If you go to pcper.com/mining, MINING, it takes you directly to that story. So pcper.com/mining takes you to that story if you want to see how to set up your system. It's a really super easy process. And you can donate that way.
Don't misspell it to Minge, because it's going to go someplace totally different.
Oh no, let's still go to the Gingers.
Yes. Yeah. Oh yeah. Sure. Everybody's
3 for
got that
3
wallet out there. Oh man. Okay.
We need to quit before Josh turns
So
completely red.
pcpro.com/mining. The other URL to know is pcpro.com/podcast. That's where you can find the show notes, the video, the RSS, the MP3 files, like if you want to direct download the video files, all that stuff is available there. If you're not already, and also it has a little reminder about pcpro.com/live and our Wednesday 10 p.m. Eastern, 7 p.m. Pacific schedule for all that. So thank you for everybody for hanging out tonight. And getting through some major processor discussions. But hey, it's exciting times. It's exciting times. That's all I got. I'm Ryan Shrout.
I'm Jeremy Hellstrom.
I'm Josh Walrus.
And I'm Allyn Malventano.
Bye, everybody. Intel's spokesperson apparently said we take all competitors seriously, and while AMD is trying to re-enter the server market segment, Intel continues to deliver 20-plus years of uninterrupted data center innovation. Their Xeon is proven and battle-tested, wide range of workloads, specifically designed to maximize data center performance, capabilities, reliability, and manageability. With our next-gen Xeon Scalable, we expect to continue offering the highest core system performance versus AMD's. AMD's approach of stitching together 4 desktop die in a processor is expected to lead to inconsistent performance and other deployment complexities in the data center, which is exactly what they told us when I was out there last week.
Tough words from people that invented hyper-threading.
Well,
and best yet, Pentium D utilized the GTL Plus bus to communicate between their cores, which was slow.
Didn't Intel publicly announce that like 2 generations from now they were going to do a multi-die package for Xeon? They were going to have to.
I think it's Xeon and plus the their GPU multi. What is it? The Knight's Corner, Knight's Lake, Knight's Crossing.
You're talking
Landing,
about the
crossing.
You're talking about the
they're going to have CPU plus kind of their GPU and a package that will have memory on there as well. And
okay. I do take.
I don't know.
I do take like Intel's been very heavy-handed with the stitching together 4 desktop dies, whereas AMD will swear that the Zen architecture was designed for server, and if anything, it was adapted down to consumer spaces the other way.
Well, I mean,
and they said very openly like they could not make the 32-core processor today on a single monolithic die because there are the lithography equipment doesn't have a reticle that size. Now, I don't know how to verify
the heat would
that.
be insane.
No, I mean it could. I mean,
you could do it, but it's going to be an 800 millimeter square part. So each Zen is what 195 millimeter square, 192.
I don't know the answer to that off the top of my head.
Somewhere, I mean, you could cut stuff out because you've got South Bridge functions in each die, but those are relatively small as compared to the rest of it. So yeah, it's supposedly what NVIDIA is doing with their top end Volta stuff that are 800 millimeter square that they're talking about, but until we can get the calipers out and measure that crap.
I mean, Josh can probably correct me on this, but the Opteron 6000 series, the Interlago stuff, was kind of just shoving 2 bulldozer CPUs together in one package, right?
Yeah, it was used in hypertransport.
Yeah, so this is something AMD has been doing.
Multi-die packages have been around for a long time. I mean, that's how we got. That's how we got 2-core processors to begin with.
That's where we got Pentium D.
Yeah. Sure, but the Opteron 6000 was. It looks like kind of the analog to Threadripper. It was 2 AM3 processors stacked together essentially on an LGA.
Yeah. Don't get me wrong. There are benefits to having a single monolithic die, and if you look at like latencies between die are going to come into play, right? And it's all about what workloads that affects. But AMD talked about the benefits of having the 4-die package is that they could get more transistors onto a processor than they could if they went to a single monolithic die, right? Because there was no reticle big enough to do what they wanted to do. They get the financial benefit of having this incredibly high yield because they can now sort very well, right? They get what was the other? There was a third point to this. Cool story, huh?
Probably you're going to expand out the heat of the entire thing because it's all not one monolithic die. They're 4 spread out.
Hang on. Talk amongst yourselves. I got my notes in here.
I mean, next thing you know, you got like microfluidic channels going through your damn CPU on water cooling just to try and keep it at a reasonable temperature.
Right.
Which would be interesting to try and pull off.
So, Josh,
it actually might make the substrate and pinouts a little bit easier to design around without a monolithic die.
Sure.
True.
But go ahead, Ken.
Would a theoretical, well, I guess they've announced it, Zen plus Vega APU be using Infinity Fabric to link the two together?
Probably
or would
not,
it be
unless they built that directly into the Vega architecture.
Well, I mean, Infinity Fabric.
What I understand, Infinity Fabric is, it's a way of packaging data to go over the PCI Express lanes.
Okay.
And so, in theory, they could get Vega to do that.
I still, I heard from a friend of a friend who talked to Forrest, I think it was Forrest Norrod, who's like the VP of this, said that the connection, in Infinity Fabric in this instance is an evolution of hypertransport over PCIe.
How's it an evolution of hypertransport when they bought Infinity Fabric from someone else?
They didn't buy Infinity Fabric.
Yeah, they did. C-Micro.
That's those C-Micro shit.
I think wasn't that something different?
No.
It was originally, yes, but I think they built off of it.
Yeah, I guess they could have built off of it.
I think it's an extension of what C-Micro offered.
It would just seem highly odd that it would be the next evolution of hypertransport when they bought the underlying tech from someone.
We developed our own fabric technology, and we'll just buy these guys that have a different one. And
No, Knight is right. Freedom Fabric is what it was called from C-Micro.
That's a good name.
Yeah. Okay. So I was correct. Yeah,
freedom.
And as far as I know, they really don't use anything that they purchased from C-Micro in any of their designs anymore. Like that was kind of a flop.
Maybe a bad acquisition then.
Maybe it was. All right, everybody, that's it. We're going to close out for the evening. If you enjoyed this content, consider supporting in-depth technical content by contributing at patreon.com/PCPer.